Hi, this is part one of a series on Windows and solar control that I'll be doing, modeling those in OpenStudio. Here I've got a basic model with a number of zones I'll be using as I go through this series. In this first part, we're going to focus on the first three here. Each one of these spaces has a large window facing to the south. The first one up here on the far left will be our control zone. We're not going to do anything to that. The next one, we're going to demonstrate how light can travel through a window, through another interior window, and into a second zone. And then we'll be looking at putting a basic shading device on this third space here, and then comparing some of the results. Each one of these spaces has an illuminance map and some daylighting controls in it that we'll be using to test some of our results here. So the first zone is set up. We don't need to do anything to that. It's just got a window and it's going to be transmitting daylight directly into the space. The second one is also set up. One of the key elements here is that you can see that the surfaces are matched. And so that, let's put this one first, on the back side of the space, there's a window and a surface that's set into, and it's matched with the window and surface on the opposite side there. Also note that each one of these has adiabatic surfaces on the sides so that we're eliminating any impact of shading from one onto another, and so we'll get uniform heat transfer results where we're only seeing the differences based on the shading strategy, or the solar control strategy, as I should say. So for this zone, we're going to add a shading device onto it. There are a couple of ways that we can do that. I'll demonstrate both of them here. The first one is we'll use the script. So if I go to Extensions, User Scripts, Add or Alter Model Elements, and Add Overhangs by Projection Factor, then this will add an overhang to any window in the zone that I have, or sorry, the space that I have selected. I'm going to keep the default of a 0.5 projection factor. That means it's going to make an overhang half the depth of the window, or half the height of the window, I should say. That I can design the overhang to shade at a certain angle that I predetermine, and then determine the projection factor based on that. For the sake of the illustration, I'll use that. And then the offset is the height of the overhang above the window. I'm going to say 0.1 for that as far as the fraction goes. That's going to take it up near the roof. This last choice is asking whether you want it to remove any existing shading devices that are already attached to the space. It's not relevant here because I don't have any, so it doesn't matter what I choose there. And so I've got my overhang in place now. Now, by default, that overhang is opaque, but I can also add a transmittance schedule to it to reflect either some changes that take place, if there's some operable element of it that changes over time, or something that is translucent. In this case, I've got a schedule already built into my model here. So I'm going to select the shading device itself and come down to, in the inspector, find the transmittance schedule, and I'm going to select always 25, which means, in this case, the schedule always has a fraction of 0.25, which will indicate that there'll be 25% transmittance or 75% shading from this overhang here. Now note that this is a space shade. By default it comes in, if you put this inside the zone, or inside the space rather, then it comes in as a space shade. And the key thing to know about that is that Energy Plus, when it runs the simulation, will only test to see if this shading device is shading this one space that it's attached to. Whereas if I put it in outside the space using the shading group tool, let's say I put in some object out here, let's just say I had another building or something there that I wanted to use to cast shadows on these other zones. This is now, you can tell by the purple color, it's a site shade or building shade. Actually, those function effectively the same, which means that it's going to then test to see if this is casting shadows on every single zone in here. So I don't actually have that. Let me get rid of it. All right, I'm going to save my model. I'm going to manually come back and do one more thing. I want to add a shading fin down the side here that comes off of this shade I've already got. So I can, if I navigate in, now that I have this drawn, I can draw within that shading group. And anything I draw in here is going to come in as shading element. Sometimes it's hard to get it to snap on to the plane you want, but go ahead and put it in there. And I'm going to bring it on down so it wraps nicely. Now if I hadn't already come in and put in that shading group using the script, what I would do is, I'll just demonstrate it on this adjacent one over here. I would click into the zone, then I would come in and again use this, or sorry, the space, click into the space, and again I'm going to use this shading group tool, apply that inside the space now, and then whatever geometry I draw, comes in as that space shade. Now notice the colors are different here. The light color indicates the inside or bottom face of a surface. The dark color indicates the outside or upward face of a surface. For a shading device, if it's just purely functioning as shading, it doesn't matter which way that's facing. We'll get to daylight shelves a little bit later on where it does matter. In this case, if I want to flip that, then actually before I do that, let me just show you something else here. To test that, we need to see which direction surfaces are facing. If you go to Extensions, OpenStudio, Rendering, Render by Surface Normal, white is out or up, and red is in or down. So you can see on this shading device here, it's actually facing upwards. If I double click on it, click in there and select that surface, and then right click and then reverse faces, it'll flip it. And now if I go back to rendering the construction, you can see it's facing the direction we wish. Let me get rid of that one. I'm going to save my model. Now we're ready to jump over to OpenStudio. All right, check and make sure that my weather file is attached, which it is. And we had everything we needed, so we're now ready to run the simulation. So I'm just going to click Run. This will take a little while because I've got all those luminance maps in there. So I'm going to pause while it finishes running. Okay, I've got my results. And we're going to start by looking at the results for our control zone, which had no shading of any kind, and the secondary zone here behind this one. We'll look at the daylight illumination at our control point we had in there. So I've already opened that up and plotted that here in DView. You can see we've got our daylighting reference point illuminance plotted. The blue line is for the zone 1. The control point. You can see that it's going up very high at times when the sun is low. You can see there's a sudden drop as we move from the winter into mid-spring, whenever the sun is coming up higher at such an angle that it's no longer striking that daylight illuminance reference point, all through the summer, and then jumps up again in the fall when again it drops down below that point, striking that point. It never gets to have direct impact on that space toward the back, it appears. And the values are much lower, but we can see we are getting some daylight through there. And if we zoom in here, come over toward the winter side, you can see our values are not huge, but they're also not insignificant. On many days, we're getting as high as 1,000 lux back up in there, all the way toward the back of that space. So pretty impressive for daylight coming through another zone, through a window, and into that space, deep at the back of the zone. All right, so let's look at comparing now our control space with the space with the shading device here. So again, going back to DView, first I want to look at the transmitted beam solar radiation rate, which is a variable that wasn't directly available in OpenStudio, but I used the apply measure now function to put that variable in. And I'm going to plot first that value for our control zone against our other zone. And I'm going to get to auto scale and look at the trend over the course of the year. And so we can see we're getting considerably more direct beam solar coming into that zone throughout the entire year. You can see, especially in these kind of shoulder months, there's some big gaps over here through the spring and through the fall. The shading device wasn't specifically designed to allow certain quantities of radiation in during the winter or to create full shading during the summer, both of which would be totally viable. But that's another topic. But for illustration purposes, we can see that that shading device is actually having a really significant impact. Again, if we zoom in during the summer, it's cutting down the direct beam solar radiation to on the order of 15 to 20 watts, sometimes up to 30 around the peak during the summer. So really low values. I'm going to turn off auto scale so we can get a better sense of how it changes as we scroll through the year. So if we look here around the summer solstice, direct beam values are extremely low, even when there's no shading, because of the high angle of incidence and the short period of time that the sun is even on the south facade. But as we come over here toward those shoulder months, we can see that we're getting a lot more impact from the shading device like we'd expect. And if we come all the way over down toward the winter, now we have some quite high values coming in late fall, and we're still cutting down on that direct solar somewhat. That's mainly because the shading device is very close to the top of the window. And we see something similar going on throughout the year. If we look at our cooling rate, let's compare how that is impacting us here. Now, this is a space with no internal loads, but it does have a lot of surface area, and it's got the ideal loads system turned on, so it's conditioned space. You can see at the peak of the summer, we're not getting a lot of impact. We wouldn't expect to from that shading device because there was very little change in the amount of solar gain we're getting in terms of direct beam solar gain during the summer there. But we'll start to see greater impact as we come over here into the fall. It looks like we're getting some pretty significant reductions of the peak cooling rate That even improves as you get over here later in the fall, as the shading device is really starting to have some really good impact. Some of these lower sun days, it's taking the need for cooling almost down to zero as it's cooling off. We do get some peak days, but at some point the sun's going to start getting lower, and we would see it coming in more, but also our cooling load is diminishing. So if we had a cooling load at this time, those values would be spiking back up, and now we've hit the cool side of the cycle, and that solar gain is actually helping us because in this period we likely have a heating load. So those are some of the ways that you can use solar control in a very basic way on Windows, and some of the ways you can study it. There are literally hundreds of variables that you can request either directly through OpenStudio or by adding them into OpenStudio using the Apply Measure Now tool, and to study many of the different factors that are impacted by solar gain here. In the next series, we're going to talk about blinds, shades, and screens. So I'll see you there.